Thank you for joining us again. Today we have with us Osmar Zaïane, who is a professor of computing science at the University of Alberta and a fellow with us here at Amii, the Alberta Machine Intelligence Institute. Osmar is an expert in machine learning with a focus on pattern discovery and information extraction. Osmar, welcome. Thank you for joining us today.
Thank you.
I'm wondering if you could quickly introduce yourself and tell us a little bit about your research interests.
Well, as you introduced me, I'm Osmar Zaïane. I'm a professor and researcher at the University of Alberta. I started about 20 years ago. I am also a fellow with Amii and CIFAR Canada AI Chair. When people ask me, what are you working on? I often say, well, I'm working on things that are related to everyday stuff. So people say, how useful is it in my own life? Well, I tell them I'm working on effective ways to discover patterns and irregularities in complex data that can become actionable in real applications. And this applies to all fields in our everyday modern life, from medicine, finance, business, or computer games.
That's fantastic. So it sounds like you have a lot of different research interests and a lot of different avenues that you follow. Can you maybe tell us about one particular project or research avenue that you're really interested in these days?
One of relevance here is the topic of social network analysis. It has nothing to do with social media. Social media could be part of it, but it's basically the discovery of structures in large graphs. Social networks are graphs of entities and their relationships. So you see, records and data in the database are not independent. We look at them as independent entities, but they are interrelated with relations. These relationships form graphs, and I work on predicting links that are not observed, so these relationships, but also on discovering communities, nodes that are more related to each other than with other nodes in the graph. It is, in a sense, partitioning the graph into relevant groups. These groups could overlap or be disjoint. When you have a very large graph, this is a very challenging task. And I work on effective and efficient methods to do this, whether the graphs are large but simple, or attributed graphs that we call probabilistic graphs. These are graphs that have relationships with uncertainties attached to them.
So an area of research that sort of focuses on the interactions between different entities within an ecosystem or within a network and looking to better understand and map out those connections. Is that right?
Yes. And it gives us a different perspective on the data. Understanding how these entities and the data interact can provide us with insights that we wouldn't have if we assume that they are independent. So, for example, understanding the customer base. So relying on approaches using features and attributes of, for example, gamers, disregard rich user data that is already there, that is not necessarily explicit, but implicit. We can, for example, provide explainable data-driven personas of gamers to better tailor products and recommendations of in-game purchases, for example, tokens and passes and so forth. So it gives us a better perspective on what's going on.
That seems like social network analysis would be very useful for us in, better understanding the player communities and how people are interacting with one another.
Exactly.
Do you just take a particular snapshot in time, or is this something that we can understand how a community changes?
That is a very good question. So you can do this analysis on a snapshot. But in many applications, those graphs are not static. They change. You have nodes that come, nodes that go, and you have new relationships. So what happens is that you have these communities that I talked about, these groups. They grow and they shrink, they divide, they merge. You have entities that move from one group to the other. So there is a dynamic graph also analysis that we do, and it's very, very useful. It shows you how things are changing, how your set of customers or game players or whatever are changing, and their interaction changes. And that is very, very useful in decision making.
Well, wonderful. Thanks very much, Osmar, for sharing your research with us and talking to us a little bit about how social network analysis could be useful in video games. Thanks so much for joining us today.
You're welcome. Thank you.